solving rational equations. We're going to look at word problems, and there are a few things I would like for you guys to take away from this. The first is solving these equations usually isn't that difficult. What I find most difficult about this is actually setting up the equations. And lastly, when you get an answer, what does that represent? And have you actually answered the question being asked of you? So let's just dive in. We'll look at our first example, which you should see now. So Richard competes in a race. He cycles for 120 kilometers, then runs for 12 kilometers. His average cycling speed is 6 times faster than his average run speed. Really, that's just saying he cycles about 6 times faster than he runs. It took Richard a total of 8 hours to complete the race. How fast does Richard cycle? So I'll give you guys a second just to kind of take that in. Maybe you'll want to copy it down. The other piece of advice that I'll give you is there's a lot of information presented. Actually, just try to read through this again. You may find yourself processing things a little better if you read it a second or a third time. But essentially, what we want to do is set up our equation for this. So let's begin. And where I always start with this is we're talking about distances, we're talking about time, we're talking about speed. I always like to recall that velocity is distance divided by time. Moreover, I'd like to say that time is distance over velocity. I found that these two equivalent equations really help. So let's take a look at this. And I'm going to kind of divide this into 2 times. You have, time 1 where Richard is cycling and time 2 where he is running. We know that the combination of these 2 things is the total 8 hours. So that's going to be my first kind of equation. That 8 is equal to time 1 plus time 2. Now, time 1 represents cycling. Time 2 represents running. So I'm going to set up distance over velocity for both of those things. So for cycling, the distance is 120, and the velocity, we don't know exactly what that is, but we do know that he cycles 8 times faster than he runs. So I'm going to leave that be for just a moment. I'm going to go over to the running, which is going to be, I'll say 12 over x. 12 being the distance over the speed at which Richard runs. We also know that he cycles, so I'll come back to this, he cycles 8 times faster than that speed. So I can put 8x there. And this represents time 1, 120 over 8x. Time 2 is represented by 12 over x. So I can put those 2 expressions into our equation that we have here. So this becomes 120 over 8x. I'm sorry, I misread that. And that's the other thing. We want to make sure we're doing everything as correctly as possible. This is not over 8x. It's actually over 6x. His average cycling speed is 6 times faster, not 8 times faster. So That should be our expression for this. And then we're going to have plus 12 over x. And so at this point, we have one equation and one unknown. And so we can solve this. So let's go ahead and do that. And like I said, the solving part really isn't as difficult as the setting up part, I find anyway. You may be feeling different after you practice this a little bit. However, let's solve this. I'm going to multiply by x to begin. So I have 8x is equal to, if I multiply by x here, it cancels, as well as here. So I only have to multiply by x once, and I get 120 over 6 plus 12. Okay, well, 120 over 6, that's just 20 plus 12 is equal to 8x. And so, therefore, 8x is equal to 32, and x is equal to 4. Have myself an answer. So, that's our solving process. We get ourselves an answer, and I want you to come back to what does the question ask us to find? So I'll bring that up again. How fast does Richard cycle? Well, what does x represent? Here's x. X represents how fast Richard runs. So this is not our answer. It's related to our answer, which is that Richard cycles 6 times faster than that. So Richard's cycling speed is 6 times 4, which is 24 kilometers per hour. Okay, let's try another one. Bring this up. So, the sum of the reciprocals of 2 consecutive integers is 11 over 30. What are the integers? For being such a short amount of words, there's a lot of information packed into these statements. So the sum, that means we're adding, of the reciprocals, so we're going to have some fractions, of 2 consecutive integers is 11 over 30. So 2 consecutive integers. So integers means we can be positive or negative numbers. 2 consecutive integers is saying that the 2 integers that are represented by this statement are one after the other. So, for example, -4, then -3. Or perhaps 4 and 5. Or 11 and 12. And so that's so much information, and we've got to figure out a way to represent this with an equation. So let's go back to our paper. And here's usually how I start these questions. I know that the sum of 2 things is equal to 11 over 30. Okay. The sum of 2 consecutive integers, but we're dealing with reciprocals. So, the way this looks is the first reciprocal integer is 1 over x. And the second is 1 over x plus 1. So, if x was 5, this expression here would be 6. So that's kind of how we do the consecutive part here. And the reciprocals are represented by 1 over each. So now we just go ahead and solve this. So we'll do this one thing at a time. Let's multiply by x here. I'll just get 1 plus x over x plus 1 is equal to 11 over 30 multiplied by x. Now let's multiply by x plus 1. As much as I may want to cross this out, the fact that it's x plus 1 on the bottom means that I cannot. So I have to multiply by x plus 1 to cross that out. The x still remains. And I have over here 1 times x plus 1. Well, that's x plus 1. Plus another x, that's gone now, is equal to 11 over 30 x multiplied by x plus 1. Okay, so on the left side I have 2x plus 1 is equal to 11 over 30 x squared plus x. Okay, so go to a new page now. That 11 over 30 is kind of, I don't want to distribute that in, so what I'll actually do is I'll multiply everything by 30 to get 60x plus 30 is equal to 11x squared plus x. Common idea of just getting rid of all the denominators can make things easier, I find. So 60x plus 30 is equal to 11x squared plus 11x. Combining everything to one side, 11x squared minus 49x minus 30. And that is that's a quadratic, so we can solve that. We'll do so here. 11. So we get 2 answers when we solve it, however it is that you solve. You get one answer that's 5, and you get another answer that's negative 0.54. We don't care about this answer, even though it solves the quadratic, and it would even solve our equation that we started with in the beginning. It is not an integer. It's not a whole negative number. It's decimal, repeating decimal, so we cross that one out. And so our numbers, remember our question was, what are our integers? Well, this solves x is equal to 5. So that's one of our integers. And the other integer, so x is equal to 5, so our integers are 5 and 6. Because it was x and x. Okay. So we'll do one more. Okay. So we have Jillian drives 304 kilometers in the same amount of time it takes Megan to drive 256 kilometers. If Jillian drives 15 kilometers per hour faster than Megan, calculate Jillian's speed and the time taken for the journey. Okay, so lots of information. Some of it a little more elusive than others. I'd say one of the key ideas, we're still doing, velocity, distance, time, but the phrase in the same amount of time, that actually tells us something very, very important. And I'll show that here in a moment. same amount of time. Okay, so sample 3. Sometimes like to draw a picture for this. So 256 kilometers per hour, and we'll say the speed is x. And that represents Megan. Jillian is represented through 304 kilometers and drives 15 kilometers an hour faster. So that's x plus 15. Now finally, we want to know this total speed. So we're going to figure out x, and then we're going to have to add 15 to it for our answer. And we want to know the time taken for the journey. The piece of information that, and I've actually set this up to be distance over velocity, distance over velocity. We know that the time each of these journeys took was exactly the same. So this journey is 256 over x. That's distance over velocity. That represents time. And this time is represented by 304 over x plus 15. Well, it turns out that these two times are exactly the same. So, in fact, these two expressions are equal to each other. So 256 over x is equal to 304 over x plus 15. And now we go ahead and we solve this. So we shall multiply by x and multiply by x plus 15. So we're going to have 256 times x plus 15 is equal to 304 multiplied by x. So 256x plus 15 times 256, which is 3,840, is equal to 304 times x. So I'm going to subtract 256 from both sides. So 304 subtract 256. That's 48x is equal to 3,840. Divide both sides by 48. And I get x is equal to 80. Alright, so x is equal to 80 kilometers per hour. That represents Megan's speed. So therefore, Jillian's speed is 80 plus 15, which is 95 kilometers per hour. So that's our first answer. Second question is, how much time did the journey take? Okay, so answer that here. And we'll do it in two ways. Time is represented by 256 over x, which we now know is 80, or it's represented by 304 over 95. So if we do those two ratios, 256 divided by 80, that's time is equal to 3.2 hours. And here's to hoping that so is that one. So that answers our second question. Time is 3.2 hours. That I hope is making a lot of sense. Like I said, I don't find solving the problems too difficult. I actually find setting them up to be the hardest part of all of this. So keep that in mind. Take all of the information in that you can and do your best to set up these equations. Hope that helps.